Topics in Math 4.4 Euler Circuits and Paths. An Euler circuit is when you begin and end at the same vertex. So we're going to keep working with these graphs. But if you can make a graph where it starts and stops at the same spot, that's an Euler circuit, and trace each edge exactly once in the graph. So for example, if you had 4 dots here, and you wanted to connect them, you want it to end back up at the original, that's called an Euler circuit, okay? An Euler path is when you begin at a vertex and end at a different vertex, but traced everything exactly once in a graph. So we could take those same 4 points, but just connect it differently. So notice we started at this point up here and we ended down here. Start and finish. Where up here, start and finish was the same point. So for the circuit, you're going to start and finish at the same point, but for the path, you will start and finish at a different point. All right, example 1. Would this be an Euler circuit or an Euler path? So what we want to do is pick a point to start at. There might be more than one way how to pick a starting point, but we're going to pick D, okay? So we want to cover all of these edges by connecting all the vertices, but you can only go through and you can only trace an edge once. So if I went from D to E, and then from E to B, and then I'm going to go to A, and then to D, and then to C, okay, and then we can go back to A, back to E, back to C, so A, E, C, and finally B. So if we look at our first and last point, telling if this was an Euler circuit or an Euler path, notice these first and last letters are different. That's going to say it's an Euler path. Okay, let's try the next one. Go ahead and start at A. Why don't you guys pause it and see what you come up with. See if it's an Euler circuit or an Euler path, and then write down the order that you wrote your letters in. All right, so I went from A to E to B to D to C to B to A. There's a lot of different ways you could have made that same path, but the key is noticing that the first and last letter are the same. So this would make an Euler circuit. All right, now what makes up, how could I right away tell if this was a circuit or a path? So let's look at some tricks here that we can right away tell. How can we determine which one it is? Okay, so the Euler circuit exists if all vertices are even. So when we're figuring out how many edges are coming from each vertex, if they all have an even number, it's going to be an Euler circuit. An Euler path exists if there's exactly 2 odd degree vertices. Okay, and if you have neither of these, it's probably not a path or a circuit. Not an Euler path or a circuit. All right, let's try example 3. So right away, we can figure this out by finding the degree of each vertex. So I'll just start at A here. So look at how many edges were coming from A. So 4. I'll go to C, had 2. B, 1, 2, 3, 4, 5. D was 3. 1, 2, 3, 4. E is 4. And F is 2. Okay, so we can tell that since there was 2 odd degrees here, the 3 and the 5, that this is going to be our Euler path. Okay? So now what we want to do is come up with what that Euler path is. Okay? So let's go ahead and start at B. Okay? So if I start at B, I'm going to go from B to A to C to B to F to E to D to B to E to A, and then finally to D. So notice we're only tracing over these one time. Okay? And then we can confirm our idea that it was an Euler path by noticing that the first and last letter were not the same. We did not start at the same vertex that we ended at. So again, this one would be the Euler path. All right, let's try another one. All right, why don't you guys pause the video and figure out how many edges are coming from each vertex. And then once you do that, think about if it's an Euler path or an Euler circuit. So go ahead and pause the video. All right, this one's going to be an Euler circuit because all of your degrees were even. Okay, so that means we're going to start at the same place that we stop at. So pick a letter to start at. So I started with D. This one's going to have a long series of letters here. I kind of did that inside part there. So D, B, A, E, C, B. This one goes clear around to H, to I, to E, to H, to G, to E, to F, to G, and finally all the way back up to D. Okay, so again, notice that the first and last letter matched up, which makes it again an Euler circuit. Okay, so for your assignment, we're going to just do part of the assignment today. We have a little bit more to talk about tomorrow. So 4.4 part 1, page 195, numbers 1 through 4. So go ahead and get started with that, and we'll go from there.